Here's a 10.8 notes, vectors, page 5. And so now it's time to kind of pull together and talk about all the terminology that we have used at this point. So on the first page, when we were introducing vectors, we talked about the initial point and the terminal point. Okay, so the initial point is where our vector starts, and our terminal point is where our vector ends, and that is that end with the arrow on it. The position vector is basically the component parts, our x and our y, that gets us from that 0, 0 to where our vector ends. Keep in mind that vector is exactly the same no matter where it's placed on the coordinate grid. We like the position vector when it starts at 0, 0 because then we don't have to subtract component parts to figure out how long that x piece is and how long that y piece is. We also talked about the magnitude and direction. The magnitude is the size or the length of the vector, and the direction is the angle that's made with the x-axis. It tells us what direction that vector is pointing, okay? And I've used the word horizontal component and vertical component. Here we're going to break them apart, and we are going to write that horizontal component as just the x piece. So we're going to write that as the vector A0 that is going to tell us how far we move in the x direction only. Notice that our y component is 0, so that does not move up or down at all. And then we're also going to talk about our vertical component, how far we move in the y direction only. We can write that as a vector as well. 0b, again, that 0 and that x component means we are not moving horizontally at all. Okay, so let us focus on that horizontal and vertical component right now. Example 10, you're asked to find the components of the vector. So we just want this written specifically as the x piece and the y piece. So to find that x component, I'm just going to look at the x parts. So my terminal point is 7. My initial point is 3. I'm not worried about the y component at all, so I'm just going to make that a 0. My x component is the vector 4, 0, my horizontal component. I can do the same with the y. This time, though, I don't care what's going on in the x direction. I just want to deal with that y shift. My terminal point is 4. The initial point is 2. I get that vertical component of positive 2, so 0, 2. Okay. Sometimes it's important to find a unit vector that's going the same direction as whatever vector we're talking about, v. So we want the magnitude to be 1. Anytime the magnitude or the length of the vector is 1, we call it a unit vector. Unit means 1 unit, 1. Okay, and we're going to define our unit vectors in terms of components. So that horizontal unit vector, we call this I. It's going to move just 1 to the right. So here's my horizontal unit vector. It's the vector 1, 0. Our vertical unit vector, we call J. And that just moves 1 in the vertical direction. So that's the unit vector 0, 1. Okay, now we're going to combine all this together. If v is any non-zero vector, then the unit vector is the component parts divided by the length of v, so divided by the magnitude. So any vector divided by its magnitude is a unit vector. So let's take a look at what this looks like. Here's my vector v, negative 14, 2. I need to start by finding the magnitude of that. So again, we like that position vector. We can just square the component parts. I don't have to subtract anything, potentially make a mistake there. So we get the square root of 200, which we always want to simplify as we can. Just as a reminder, we can write 200 as 100 times 2. I wrote it that way because I know 100 is a perfect square. So this becomes 10 square roots of 2. There's my magnitude. So I want a unit vector in the same direction as that, and I'm going to take a look at what it told me I needed to do right here. I'm going to take my vector v and divide by that magnitude. And so I've got negative 14 divided by the length, 10 square roots of 2, and I have 2 divided by 10 square roots of 2. Here, again, we really don't want that radical 2 in the denominator. So I'm going to multiply numerator and denominator by the square root of 2. Notice I don't have to worry about that 10 times part because it's already a whole number. So you could multiply by 10 square roots of 2, and then we're going to have that factor of 10 in the numerator and the denominator, and they're just going to cancel out anyway. So I get what? Negative 14 square roots of 2 over 10 times the square root of 2 times the square root of 2, which is 10 times 2 over 20. I get 2 square roots of 2 over that same 20. I do want to simplify if at all possible. So I get negative 7 square roots of 2 over 10. And I get the square root of 2 over 10. And we shall cram that in on the right-hand side. Okay. We also want to write this as a linear combination of our horizontal and vertical unit vector. So let's think for a second here. I'm going to just lay this out for the x component. My horizontal component is the negative 7 square roots of 2 over 10. Okay, I'm ignoring that 0, which makes this negative 7 square roots of 2 over 10 times my horizontal unit vector, 1, 0. And up above, we said that that is the unit vector I. So that means our unit vector in the same direction as v can be written as negative 7 times the square root of 2 over 10 times I, which is our unit vector in the horizontal direction, plus, let's take a look at our vertical component, square root of 2 over 10 times j. And that is our unit vector in the vertical direction. And that is it for page 5.